We're going to take notes on inequalities. An inequality is a statement that one quantity is less than or greater than another. For instance, x is less than 5. The nature of an inequality is not changed when adding or subtracting any real numbers or when multiplying or dividing by a positive real number. So it will not change. It's just like the properties of equality for addition, subtraction, multiplication, division for equations. However, when multiplying or dividing by negative numbers, you must reverse the inequality symbol to maintain a true statement. So that would be examples like negative x is less than 5, so a positive x needs to be greater than 5. A solution to an inequality is the value or set of values which can be substituted to make the inequality true. So for instance, if we had x is less than 5, that was really weird, then we would have 4 if x equaled 4. I'm not sure why it's doing that. If x equals 4, that's true. If x equals 3, that's still true. If x was to equal negative 2, that's still true. This was left off from the last one. The substitution probability of equality substitution states that one name of a number can be substituted for another name of the same number in any expression. Substitution can be used if one statement is replaced with an equivalent one and no other property or definition works. That's the key. No other property or definition works. Each step in the solution of the inequality will be justified using the axioms of inequality. An axiom is a statement universally recognized as true without proof. So all our properties, we assume that they're all true. Properties of inequalities. For any numbers a, b, and c, the following are true. Addition. If a is greater than b, then a plus c is greater than b plus c. Addition property of inequality. If a was less than b, then a plus c is less than b plus c. For subtraction. If a is greater than b, then a plus the c is also going to be greater than b plus the c. And likewise, if a is less than b, then a plus c is less than b plus c. Again, subtraction property of inequalities. You do the same to both sides. Properties of inequalities continued. For any numbers a, b, and a positive c, that's the key, a positive c value, the followings are true. Multiplication. If a is greater than b, then a times a c is greater than the b times the same positive c. If a is less than b, then a times c is going to be less than b times c. For division, that's also true. If a is greater than b, then a divided by c is going to be greater than b divided by the c. And if a is less than b, then a divided by c is less than b divided by c. Again, no change in inequality. Let's go back. For any numbers a, b, and a negative c, the following are true. If a is greater than b, then a times a negative c is going to be less than b times a negative c. If a is less than b, then a times a negative c will be greater than b times the negative c. For division, if a is greater than b, then a divided by c, a negative c, is going to be less than b divided by that same negative c. If a is less than b, then a divided by c will be greater than b divided by c. So in all these examples, notice in red, all these values flipped. They all flip signs because the original c doing multiplying and dividing both sides by negative, so the inequality must flip over. Example problems. So here's some examples. If we have negative 6x plus 9 is less than or equal to 81, we would still solve it just like we normally do. We'd get negative 9, negative 6x is less than or equal to 72, divided by negative 6, divided by negative 6. We would get x, and we get negative 12, but this time we flip the inequality. And example number 2, we would distribute this times this is negative 32x minus 56 greater than or equal to negative 88. So we would add 56, add 56. We would get 232 negative. It is greater than or equal to negative 32x. Divide by negative 32. Divide by negative 32. And so those would cancel. And that would be 1. And that'd be x. And we would have to flip the inequality for this here. Now for graphing these, we would graph this on a number line. Negative 12 is our number. We would circle and dot it here. Negative 13 would be here. Negative 11 would be here. And since it's greater than here, it would go this way. For the other one, graphing it, we end up getting, again, there's our number line. Here's 1, here's 2, here's 0. Again, we would close the circle because it's closed, and x is bigger than that, so we would go to the right as well. Some practice problems are justifying. Just like with equations, there can be no solutions, all real solutions, and regular inequality solutions. So here's an example of a no solution. All right, negative 2x minus negative 2x. We get 5 is greater than 9. That is not true right here. This is not a true statement, so we would say no solution. When it's all reals, negative 2x, negative 2x, we get 5 is less than 9. That is true, so this would be all reals. And then, of course, the regular solutions where you can have an inequality as an answer. We get 2x is less than 4 divided by 2 divided by 2. X is less than 2. So we would graph it on the number line to show all the solutions. 2, 3, 1. Circle, open, going to the left from there. Practice problems. Go ahead and write down these 2 practice problems, solve them on your own, and bring them back. And a joke today. What did the acorn say to the tree? He said, "Gee, I'm a tree." Haha,